Welcome to the deep dive. Today we're digging into the areca nut. It's used globally, it's psychoactive, but it's also a class I carcinogen.
Yeah, and our mission here is really to unpack why it's so uniquely toxic, especially when you compare it to something like nicotine, which people might be more familiar with.
Okay, so where do we start? The initial picture seems, well, confusing.
It really does.
Yeah.
So when researchers looked at the very first proteins each substance interacts with, the overlap was tiny, only about 16%.
16%. That sounds like they're almost completely different pathways, like apples and oranges.
Exactly. That's what you'd think initially. But, and this is the crucial part, when you look at the functional networks, the protein interaction.
So not just the starting point, but how the signals actually flow and connect.
Precisely. And there, the picture flips. Despite the different entry points, they converge incredibly fast. A huge 52% of the core nodes in their functional networks are the same.
52%. Wow. Okay, so they hit the same critical bottlenecks downstream.
That's right. These shared nodes act as signaling choke points, driving processes like chronic inflammation and ultimately oncogenesis, cancer formation.
And we know which ones these are, these core shared hubs.
Yeah, the analysis pinpoints three major ones. There's AKT1, which is fundamental for cell survival, growth, metabolism.
Right, keeping cells alive when maybe they shouldn't be.
Then you've got IL-6, a key pro-inflammatory cytokine, big inflammation driver.
Okay.
And the third one is TP53, probably the most famous tumor suppressor gene. It's like the guardian of the genome.
The cell's quality control, essentially. So both AN and nicotine mess with survival, inflammation, and this master guardian.
They share that core, yes. But then Areca net layers on something extra, something particularly aggressive that nicotine just doesn't seem to do in the same way.
Okay, so what's this extra layer?
We see two very important hub proteins that are unique to the Areca net network, EGFR, that's epidermal growth factor receptor, and MYC.
EGFR and MYC. And that combination sounds like trouble. EGFR drives growth signals, and MYC is a master regulator pushing cell proliferation.
You got it. That EGFR-MYC axis is like flooring the accelerator on cell growth. And functionally, this is a key distinction from nicotine.
How so?
While nicotine's effects can sometimes involve suppressing certain gene activities, AN, particularly driven by MYC, leads to massive transcriptional upregulation. It's turning everything way, way up.
So it's not just promoting growth, it's actively shouting, grow at the cellular level.
Exactly. And part of that aggression involves a really specific attack on that guardian TP53.
More specific than just generally interfering with it.
Much more specific. Arecaline, which is the main alkaloid in the nut, doesn't just block TP53 function broadly.
Yeah.
It specifically inhibits its DNA binding domain.
Whoa, okay. So it's not just stopping TP53 from sending signals, it's stopping it from even latching onto the DNA it needs to monitor and repair.
That's the mechanism. And by doing that, it specifically suppresses a gene called DDB2.
DDB2, and that's important
Because DDB2 is essential for a specific DNA repair pathway called nucleotide excision repair, or NER. This is the pathway that fixes bulky DNA damage, the kind caused by many carcinogens.
So AN basically sabotages the cell's ability to fix the very kind of damage it might be causing.
Precisely. And the clinical data backs this up strongly. This failure in NER, linked to DDB2 suppression, directly correlates with really bad outcomes in head and neck cancer patients, like early lymph node metastasis, poor survival rates.
That's a devastating 1-2 punch. Damage plus disabling the repair crew.
And it doesn't stop there. The analysis highlighted three other biological processes that are uniquely and strongly affected by AN, setting it apart from nicotine.
Okay, what are those?
First, extracellular matrix organization. Big impact there.
ECM, that's the scaffolding between cells, right? What happens?
Exactly. And profoundly disrupts it, leading to excessive collagen deposition and tissue rigidity. This is the molecular basis for oral submucous fibrosis, or OSF, that distinct hardening of the mouth tissues you see in heavy users. Nicotine doesn't touch ECM like this.
So OSF itself is like a direct fingerprint of AN's unique effect on the ECM, a clear differential marker.
Absolutely. Second, lipid storage and metabolism. AN forces major metabolic reprogramming. Partly through that AKT1 link we mentioned earlier, cells hoard energy to sustain that high-growth, aggressive state.
Right, fueling the fire. And the third?
Dysregulation of CDK activity. Cycle-independent kinases control the cell cycle. When they're out of whack, cells just divide completely uncontrolled. Again, something not seen in the nicotine profile.
So unique hubs like EGFR-MYC, specific DNA repair sabotage via TP53DDB2, messing with the tissue structure via ECM, reprogramming metabolism, and breaking cell cycle control. It's a multi-pronged attack.
It really is. And the analysis showed this isn't just local in the mouth. There was high protein enrichment linked to AN-MAN pathways in the lymphatic system.
Which makes sense with the metastasis link we talked about.
Right. But also, quite surprisingly, in the reproductive system.
The reproductive system. That seems unexpected. What does that imply?
Well, it strongly suggests interference with hormone-dependent pathways, and it's definitely an area that needs more investigation. It points to potentially much wider systemic effects than we usually consider.
Okay, so pulling this all together, what's the translational relevance? How does knowing these specific AN mechanisms help, say, in the clinic?
It's huge. Because we've identified these unique features, the specific hubs like EGFR and MYC, the ECM pathway changes, that very specific DDB2 suppression mechanism, these give us precise targets.
Targets for what? New drugs, better diagnosis.
Both. We can potentially develop anti-cancer therapies that specifically hit the EGFR-MYC axis in AN-driven cancers, or perhaps find ways to counteract the DDB2 suppression. And we can develop biomarkers maybe based on ECM components or metabolic changes that are specific to AN exposure and cancer risk. It moves us towards tailored medicine for these patients.
That's incredibly promising. So identifying the unique blueprint allows for unique solutions.
That's the goal. And it leaves us with a final thought, building on that reproductive system finding. If Areca nut exposure creates this specific kind of vulnerability, one that messes with transcriptional regulation so profoundly, even in hormone-sensitive systems, well, just how deep does this systemic toxicity actually go? Beyond the mouth, beyond the lymph nodes, what else might it be affecting long-term?
A sobering question indeed. Something for all of us, especially researchers, to consider as we wrap this deep dive.